If you like this video, please subscribe. Thank you. In order to adequately explain insulin resistance, one must recall some of the key tissue effects of insulin when it is released. Insulin produced in the well-fed state will have remarkable effects on at least 3 important tissues affecting their respective metabolism. Insulin exerting these effects on the various tissues will act by binding to its receptor and will initiate 2 types of effects: stimulatory effects and inhibitory effects. Starting with the liver, insulin will stimulate glycogenesis or glycogen synthesis and glycolysis. These 2 glucose-consuming pathways will use up nearly 60% of all the glucose present in the bloodstream after a meal. Importantly, insulin through its receptor will also have 2 inhibitory effects in the liver. Through a cascade of intracellular events, insulin will inhibit glycogenolysis or glycogen breakdown and will inhibit de novo glucose synthesis or gluconeogenesis, thus reducing the liver's output of glucose. Insulin will have some profound effects on 2 other tissues, muscle and adipose tissue. By specifically increasing the number of glucose transporters, GLUT4, on the surface of these 2 tissues, muscle and adipose tissue will pick up glucose from the bloodstream in an insulin-dependent manner. These 2 tissues constitute a significant portion of body mass, and as such, they can contribute to a significant amount of uptake of glucose from the bloodstream, reducing the amount of glucose in the bloodstream. In addition to these effects on glucose uptake, insulin will have specific effects on muscle metabolism. It will stimulate glycogen synthesis as it does in the liver, and it will inhibit glycogenolysis as it does in the liver, specifically in the muscle. There are 2 other noteworthy effects of insulin. The first one is that insulin will upregulate or increase the amount of lipoprotein lipase associated with the endothelium. And 2, insulin will inhibit hormone-sensitive lipase present in adipose tissue. The insulin effects on these 2 lipases will play a significant role in the development of dyslipidemia associated with insulin resistance. If you like this video, please subscribe. Thank you.